Hello, this is Eric Williams, and welcome to the latest edition of our UCS Tech Talk series. Today, our topic is going to be what's new in the world of UCS Manager with version 2.2 1B. I want to introduce my panel. We're going to start from left to right, so we'll start with David Nguyen. You can introduce yourself.
Hi, my name is David Nguyen. I'm one of the technical marketing engineers with UCS.
And Jason Shaw.
Hi, my name is Jason Shaw. I'm also a technical marketing engineer. I focus on systems management for UCS.
And Sameh.
Hi, my name is Sameh Zakhary, and I'm a product manager with the UCS, focusing primarily on UCS Manager.
No, great. So, the agenda for today is we're going to talk through some of the new features and functions that we've added in the newest UCS Manager release 2.2 1B, or codenamed El Capitan. So if you hear us say El Capitan or 2.2, those are the same things. We're going to split these things up into three different usages. We're going to talk a little bit about some of the compute changes we did, some of the fabric changes, and some of the operational changes. So let's start with you, Sameh. I'd like to get a little bit of understanding of what's new in UCS Manager 2.2 and what can customers come to expect.
Right, thanks, Eric. So like you mentioned, the main changes and feature enhancements in El Capitan are primarily around three main buckets. There is fabric, there is compute, and there is operational enhancements. And by fabric, we mean those things that we do at the fabric or NXOS level. And at the Cisco VIC adapter level as well. Compute enhancements are enhancements and features that we do at the BIOS and the server compute elements, so all of the monitoring and management capabilities of the various compute elements on the servers. And finally, operational enhancements are those things that we do to simplify the system administration of UCS, so make it easy to configure, manage, and operate UCS.
No, that's great. I think it would be good to start with the fabric enhancements, if we can kind of get an idea of what kind of fabric enhancements we've added in 2.2.
Absolutely. The first and one of the key enhancements on the fabric side is fabric scaling. And what we're doing with fabric scaling is we're trying to support larger customer environments by providing support for more VLANs, more virtual interfaces, more adapter endpoints, and more IGMP groups. As you can imagine, this is very important for cloud IT environments and service provider environments. We're also adding support for IPv6 management. So that's allowing management of both the Fabric Interconnect and all of the UCS servers over IPv6 addresses. Those customers that do use Cisco's UDLD, so the Cisco Unidirectional Link Detection Protocol, can also take advantage of the support coming up in El Capitan. This is allowing them to faster detect and converge in cases of either broken bidirectional links or wiring misconfigurations. There are also a couple of I/O performance enhancements that we've done in El Capitan. So at the Cisco VIC level, we're supporting high-performance compute applications, so HPC type applications that require low latency. And we're doing that by supporting a feature on the Cisco VIC called User Space NIC, or USNIC. Now, this feature allows those specific MPI type applications that are running on bare metal host OSs to bypass the Linux kernel and talk directly to the adapter. On the same side with the I/O performance acceleration, we're also supporting for customers that use Microsoft Windows Server and Hyper-V. We're supporting Microsoft Windows Virtual Machine Queues. So again, supporting VM queues to help improve VMIO performance where, in cases where VMFAX is not a possible solution. So, again, to sum it up, we have fabric scaling. We talked about IPv6 management. We talked about UDLD support, USNIC support, as well as VM queues. And of course, my colleagues Jason and David are going to talk about these in more technical depth in the following sections.
Exactly. Well, we'll definitely show do some demos and whatnot of some of these features and such. So I know you also said there's a second area that we're really focusing on. It's operational. What's your view of the key elements that we've done to change the operational experience for a UCS Systems Administrator in El Capitan?
So operational enhancements continue to be a major focus for us. One of the main things that we're trying to do is to make the life of a UCS system admin much easier and simpler from a management and operation standpoint. The first thing that we're doing is we're trying to allow customers that have rack mount servers, so C-series servers, to connect those servers directly to the Fabric interconnect without requiring a fax in the middle.
What's the benefit of doing that for a customer? What do you view as the big benefits?
That's a good point. So remember that we're trying to provide the same four-factor freedom and the same benefits that blades get under UCS to the rack mount servers. Now, if a customer does have a majority of blade deployment and a few rack mount servers on the side, instead of, today they have one of two options: either run them in standalone mode, or if they want to get the benefits of UCS Manager, they have to purchase a fax and connect these servers through the fax to the Fabric interconnect. What we're doing in UCS Manager is providing this economical trade-off where customers can directly connect those servers to the Fabric without having to invest in a fax. Now, for customers that have a large deployment of rack mount servers, they can still use a fax to get to the Fabric interconnect.
Okay, I know that's something Jason's going to talk a bit more about exactly what we support today with or without effects. So we can delve into that here a little bit later. So what are some other things that we get as operational enhancements?
So on the next, we're looking at strengthening the security on UCS Manager login. So we're looking at strengthening the authentication mechanism with two-factor authentication. That will require a user to provide a generated token along with username and password in order to get into a UCS Manager or a KVM session. So in examples of implementations that we have supported with that are the RSA Secure ID, and that is also, we've tested with Semantic VIP Enterprise Manager, Enterprise Gateway.
So for those customers that are very security conscious, that require every time you log into a server or their laptop, they can use that secure ID or token to be able to log in. That's a great addition.
Exactly. We're also expanding our ecosystem support, our UCS Manager ecosystem support. We're adding integration, full integration of UCS Manager with Microsoft SCVMM, and this is allowing customers to configure VMFX on their Hyper-V hosts from a central location. Before El Capitan, they would have had to go to every single Hyper-V host and configure VMFX manually.
So it gives the same type of capability that you'd have previously, like with VMware and such, where you can see that information right from the UCS Manager and configure all of your profiles and such.
Exactly. We're also enabling the management of SIMC, or Cisco IMC, through the in-band management interface, meaning management traffic for SIMC goes through the data path through the Fabric interconnect uplink ports. So this is also some addition that we're doing in El Capitan.
Okay, and so what's some of the benefits of being able to use in-band, in-band SIMC?
So that's a very good question. First of all, we're looking at the separation of management traffic. So separating the UCS management traffic from the server management traffic. And this is useful in cases where a system admin, a UCS system admin, does not want the server management traffic to go through the same management interface as the Fabric. Now that obviously frees up some of the bandwidth available on the Fabric interconnect management interface. And as it turns out, this is also the only way of getting access to SIMC through over an IPv6 address. So in order to manage SIMC over IPv6 network, you have to go through the in-band interface. And I'm sure David is going to cover that in more detail.
Exactly. So is there any other cool enhancements that we're adding in El Cap that you'd like to highlight before we switch over to you?
Yeah, a couple more on the operational side. So there is also direct KVM access. So today, in order for customers to get to the KVM, they would have to go through the Fabric interconnect, specifying its IP address or launching the session from within UCS Manager. One of the enhancements we're doing, go ahead.
No, go ahead.
One of the enhancements we're doing with El Capitan is we're allowing those customers to specify the SIMC IP address directly in the URL bar, and they can get to SIMC directly with that IP address.
So that means it allows me to go to my browser, put in the SIMC IP address, and then it's going to pop up like a login window that I can provide my credentials, and then I'll get the KVM launched from there instead of having to open up the KVM Manager and UCS Manager?
This is exactly it. And again, if you're a UCS system admin, you don't want to provide the IP address of UCS Manager to your server admins, now you can do that separation again.
Okay, and is that supported on both in-band and out-of-band, or just one or the other?
This is on the out-of-band only. So this is supported only on the out-of-band. The Fabric Interconnect has to intercept that traffic.
Okay.
Finally, on the operational enhancement, we're looking at firmware upgrades and firmware consistency on across the UCS domain. We've done firmware auto install in Delmar that automated the upgrade process of UCS Manager. We've also done a Fabric HA firmware auto sync in Delmar MR1, meaning a new Fabric interconnect that is coming into a new cluster gets to sync its own firmware version to what's existing in the cluster. Today with El Capitan, what we're doing is we're extending that to the servers. So if a customer gets a new server or an automate server and plugs it into the UCS domain, we can automatically sync the firmware that is configured on the domain to that server through an server firmware auto sync feature. And that's a policy that we expose. Customers can enable it or disable it as they like. So this is the last one of the operational enhancements that we have in El Capitan. As you can see, a large set of features spanning in-band management. We talked about direct KVM access. We talked about server firmware auto sync, directly connecting the C series to the Fabric interconnect, and I believe two-factor authentication is the missing one.
So great, that's a lot of great things. So what do we have on the compute front for folks that want to be able to manage their servers a little bit differently as well?
So remember, compute enhancements are those enhancements that are focused on the BIOS and that are focused on the server compute elements. So to start with, we are supporting Uefi secure boot, starting with El Capitan. So this is based on the Trusted Computing Group's spec, and this is a standard implementation, allowing the Uefi BIOS to authenticate the different Uefi images prior to execution. So the goal is obviously to enable a chain of trust on a Uefi enabled platform. One of the other things we're doing is enhancing the monitoring capabilities for our local storage. So this has been quite limited in the past. With El Capitan, we're getting to a definition of a new out-of-band communication channel that allows us a near real-time monitoring of our local storage.
So which out-of-band communication channel are we using to do that monitoring?
So by out-of-band communication channel, I refer to a new interface that we have developed between the SIMC and the RAID controller. So without installing any host-based utilities on the customer OSs, and without requiring reboots or server re-acknowledgements, what we're able to do is get all of the storage information, status of the controller and the local disks, through that out-of-band communication channel all the way from the RAID controller to SIMC to UCS Manager.
So that gets me in things like if a drive were to fail or a volume has problems, and I can actually see some of that configuration that I've done through the utilities from LSI and such to see exactly how I've configured that particular server storage, correct?
That's exactly correct. That's exactly correct. We're also enhancing our boot policies with a feature called Precision Boot Order Control. What we're doing is we're allowing customers to specify any type of boot device and specifying multiple instances of boot devices into their boot policy. So that could be an SD card as a boot device, which was not supported before. You could specify a USB device. You could specify SAN, LAN for Pixie, vMedia, all of that, and reorder it however you want, and the system takes care of applying the proper boot order in your system. So that's also coming in El Capitan.
So that's something that we didn't really have before. In the previous boot policies, we've only would get to what I say the first level of boot. Do you want to boot from a hard drive? Do you want to boot from LAN, SAN? We can actually now specify each of those elements.
Exactly. You can actually specify them and specify them in the same boot policy. Absolutely correct. We're also providing inventory and monitoring of the SD cards and the SD card controllers. Supporting also data redundancy with dual SD cards and supporting mirroring of the data on both SD cards in El Capitan. On the firmware management front, we're doing also firmware management of the flash adapters, so Fusion IO, LSI, and also we're doing firmware management of the hard disk drives in the system. And finally, we're also looking at providing protection for our customers with DIM blacklisting and correctable error handling. What we're trying to do is providing better accuracy at identifying degraded DIMMs. So when we call out a DIMM as degraded, we want to provide more insurance and guarantee that this DIMM is really bad. The other thing that we're trying to do is blacklisting DIMMs. So imagine a scenario where a DIMM crashes the system, hits an uncorrectable error, crashes the system. There is no guarantee that upon reboot, that same DIMM is gonna get mapped out. In fact, in many cases, it could bypass and it could pass MRC post checks, and it could be up and running in the system, exposing the customer to yet another crash. So what we're doing is we're maintaining historical data, allowing us to forcefully map out those DIMMs that we know are bad and potential risk to the customers, so that on a subsequent host reboot, these DIMMs get mapped out automatically. So this is yet another enhancements that we're doing on the DIMM side, all focused on different compute elements on the service, as I mentioned before.
So that really helps the user know that if I have a problem where I have a uncorrectable ECC error and it causes a crash on the kernel and such, that DIMM will not cause the same error in the future.
Exactly.
Well, that's quite a feature-rich release. I'm curious to know if there's some things you can share about new features and enhancements that are being planned for some of the LCAP maintenance release. We don't know this covers the first generally available release of our 2.2 UCS Manager train. What things can you share about the future of this particular 2.2 UCS Manager train that could be coming down the path?
Sure, Eric. So of course we're talking about roadmap now. So remember that all of these are under development and so subject to change. But some of the main focuses that we're looking at is supporting the new server platforms, so the Ivy Bridge server refreshes, and supporting the new EX, Intel EX server platforms, 2-socket and 4-socket. So you should see those servers being released along with one of the El Capitan maintenance releases. We're also looking at doing some enhancements on our private VLAN implementations, our PVLAN implementation. So today we support isolated VLANs. We're also looking at supporting community VLANs in a subsequent maintenance release. One of the other things that we're looking at is making it easier and simpler for a system admin to programmatically mount virtual media. So there is a feature coming up that is called scriptable vMedia. It's going to allow a user, in that case could be another program, to programmatically mount scriptable vMedia for purposes of boot and so on and so forth. So no, these are just a couple of of things that are coming up that we're planning for. Of course, there'll be more, but I don't want to steal the time from the subsequent sessions. So let me just give it back to you and Jason and David.
No problem. Thank you, Sameh. So I want to switch over to David, and I wanted to delve a little bit deeper into some of the information about the fabric enhancements that we're looking to do. Can you share some information about a little bit more detail about the fabric scaling and how that changes from earlier UCS Manager release to the current 2.2 train?
Sure. So LCAP is a very exciting release for us because it's a very rich features involvement. Also, we also increased our scaling from the standpoint. So let me just bring on some slides just from a visual standpoint and let you guys look at the numbers that we have here. And apologize. And so here are some of the numbers that we increased in the fabric scaling. As more of our customers from enterprise start going to the IT type of cloud deployment scenario, scale starts becoming a big factor in that area. It's not uncommon in the service providers, but in enterprise, again, as we get into those models, it gets very important. So prior to this release 2.2, in our Delmar release in 2.1, our current scales were 1,000 for VLANs, 2,000 for VIS and IGMP groups and endpoints that shows there in the slides. On the right, we increase for the VLANs in LCAP 2.2 to 2,000 VLANs, And the number of VIFs, they're actually the virtual interfaces, and these are virtual interfaces from a domain perspective, or we're talking about the VNICs and the VHBAs, has increased to 2,750. And for groups, multicast groups, if you're a very heavy multicast group, such as in CCTVs type of deployments, we increased it up to 4,000 groups. And the endpoints we increased from 160 to 240. So here are some of the numbers that we increased from that standpoint. From an endpoint standpoint, just for clarifications, from 160 to 240, this does not mean the number of servers within UCSM domain. That still stays at 160. To 240 represents actually the I/O adapters that we have increased, because if you remember in our M1 and M2, we supported only one MES card for I/O adapters. In the M3 cards, or M3 blades, we have increased it up to 2 adapters to give you better resiliency from a I/O perspective. So with M3 blades, you can definitely need more endpoints, so we increased that up to 240.
No, that's great. I'm curious, David, what do we actually support from this, from the Fabric Interconnect perspective? Do we support this across both 6100s and 6200s?
Good question. These fabric scalings are both for 61s and 6200s, so these scale numbers are supported for both of the generations.
Oh, great. I know Sameh talked previously about, we talked about some of the need for IPv6 management support. What are we supporting with IPv6 in UCS Manager, and what services inside of the domain is supported?
So for V6 support, we broke it down to 2 different components, as Sameh has talked about. The first one, we talk about the UCS management from the Fabric Interconnects perspective, okay? And the second one, we'll talk about the compute actually on the SIMC. So let's focus on the Fabric Interconnects on side of it. On the Fabric Interconnect, now we expose the V6 capability, and it's for a lot of customers that we're hearing that are having requirements that they need to convert over to V6 addresses. So within the Fabric Interconnect, you can now configure IPv6 addresses on both of the interconnects as well as the virtual IPs, and from there you can have your traditional services from the management perspective, where you do SSH, your telnet, if you do any syslogging or like security authentication. Before, it's now also available through V6. On the compute side, we also enable V6 as well. The V6 portion of it basically allows you to manage the SIMC on the compute side. Now, the V6 is only supported on the newer blade models, and that's going to be the M3 blades, and we only threw it through the in-band.
Oh, that's great. It would be great to see what we can actually do inside of what it looks like inside of UCS Manager GUI. Is there any way you can show us a demo of what it looks like to do V6 management inside of UCSM?
Sure. I did create a demo for you guys, and let me go ahead and bring it up for us to view how would you actually configure V6 for both on the Fabric Interconnect as well as on the compute on the SIMC. So here, to configure the V6, one thing to point out, you need to have it up and standing already. So that means you already set it up as V4. You cannot configure V6 from the startup, so V4 has to be configured first, then access into UCSM to configure it. So here, to get to it, you go to the admin tab, and right away it shows you what are the management interfaces, right? So as you noticed, a couple things here. So 2 new things. We had the V6 address for the virtual IP, and we also had a V6 tab for each of the individual Fabric Interconnects. So these are the addresses that you can configure for the management port. So you essentially...
So you can configure both the Fabric Interconnect, each of their individual IPs, as well as the virtual IP that's clustered.
Correct. So what you essentially need is basically 3 IP addresses, right? One for the virtual IP addresses, which you point your web browser address to access the Fabric Interconnect or UCSM, and then the individual IP address for the servers themselves. So here we are. Let me go ahead and configure the IP address, and I'm just going to essentially use the same last numbers just for simplification here. So in the Fabric Interconnect, you'll configure the physical interface as well as the default gateway. And you have the option to configure the prefix, which basically is the subnet mask in the IPv4 world. When you configure this, it should not interrupt any of your existing communication over your v4 because there's no changes on that side. The only changes being added is the v6. So once you configure that, it's pretty straightforward, and you just click OK. Now, just to show you really quickly, what I'm going to do is going to open up a browser here and just log in with a v6 address. So from a browser, I'm just going to use HTTP, and then within the square brackets, I'm going to put the IPv virtual manager, the VIP address in here. So it's 2100::8. So you land onto the UCS Manager. You notice that you have also your KVM Manager. So everything that you do with v4 is also available with v6. Quickly log in here. So now, as you can see, I am able to log in with v6 addresses. So the next one is I want to show you how to enable v6 on your SIM-C. Okay, so obviously very similar to your v4 when you configure for your SIM-C, it's done through the IP pools. Okay, so from the LAN you go to the pools, and we enhanced the IP pools to allow v6. Now within the same pool, you can actually have both v4 or v6, or you can have separate pools specifically for each of the IP version protocols. Okay, in this case, just to give you guys a quick look at it, I'm just going to create a new pool for v6. And so you can see from here, from this window, you have two options for add to IPv4 or v6, or you can do for both of them. Again, for illustration, we're just going to focus on v6. And you have the same assignment order where you can do it sequentially or randomly. And as we add v6, it looks very much the same way as you look for v4. You just start the starting address for v4, and you specify the number of blocks or number address you want to add into it. And obviously, you want to add in the remaining portion of the information you need.
And I noticed when you were adding the block before, you could actually also have a pool that includes both v4 and v6 IP addresses. That's correct?
That is correct. Within the same pool, you can have both v4 or v6 if you just want to keep it very simple. Or if you want to have very dedicated and very granular, then you can have unique pools for each of the protocols themselves.
Oh, that's great.
So to configure the v6, there's two methods. The first method I'm going to show you is actually through the Equipment tab. And the Equipment tab is just basically configuring the SIM-C through the Inventory tab here. So what I did is I went to the Equipment tab, drill down to the specific server, go to Inventory, and then click on SIM-C. Obviously, because it already has IPv4 automatically, I need to go to the in-band side and configure for v6. Again, v6 is only supported on M3 blades and through the in-band channel. So here, basically what I'm doing is I'm specifying a VLAN address, because remember, when we go through the in-band channel, it's actually going through the uplink, right? So usually there's multiple VLANs that's going through that same uplink with your data traffic as well as SIM-C. So here I'm specifying given the VLAN, and then here you have the option to specify which domain pool, IP pool that you want to use to get the IP address, or you have the option to do configure it statically. But since I create a pool, I'm just going to select a pool here. And once we click OK, it gets applied immediately. So if we go back to our, and there we go, we have an IPv6 for the SIM-C on one of the M3 blades.
So I want to stop here and just talk a little bit about SIM-C and some of the changes that we've done. I know we're showing some really cool things that we've changed here.
Right.
You know, with 2.2. I'd like to talk a little bit about kind of what's the legacy configuration of, you know, prior to 2.2. How did the data path work? How did it look? And how that's changed with in-band capabilities with 2.2. So I don't know if you could give me a little bit of an overview of how did it work a little bit under the covers before, and how does it work today with in-band?
Definitely. So I have a quick picture for just help us illustrate the difference in what we did before and back, traditionally prior to the LCAP release.
Hey, David, if you could just share your desktop, because I can only see your PowerPoint there. It'd be great if you could full screen that. It's only if you could just go ahead and share your desktop instead of just the app. That'd be great.
Okay. Sorry. Share the desktop. Here we go.
Perfect.
Is this better?
Yeah, just I can't see. There we go. That's fine.
Okay. So SIMC access, traditionally how we've done it through is what we call out of band, and out of band is usually your ports on your Fabric interconnect that connects to a separate management network, all right? And it goes through a separate ports from the actual data ports, or which we call the traditional uplink ports, or the 10 gig ports that you have. So to access SIMC, you basically go through your UCSM, and then the Fabric interconnect will intercept it and get you into the SIMC portion of it. Now, when you go through the out of band, we actually have a Linux stack it has to go through, and within the Linux stack, we have rules that will basically map the internal information of the SIMC information to the outside world. We also have firewalls just to block unnecessary traffic, just to protect the SIMC as well, because the importance of having SIMC available to the outside world is very important, right? We don't want to be flooded with any sort of like denial of service attack or unnecessary floods that comes into on that network to be able to prevent you from accessing SIMC. Now with M-band, what we did is basically we allow you have a different path going into connecting to your SIMC, and that's what we call through the uplink, and that's what we traditionally call M-band, because M-band is basically mean that you're going through the same data path with your data traffic. So now when you go through the N-band, you're basically exposing the IP address to your entire network.
No, that's great. I mean, this helps me understand a little bit about that it's a total different path in this case. A couple other things, and go ahead and unshare. That'd be great. A couple other things I got some questions on with regard to this as well. It doesn't really change how UCS Manager communicates still to the actual server. So, if you have in-band or out-of-band, or if you've configured both, the way UCSM communicates is still the same way it would communicate when it does things like monitors the server and reconfigures the server and associates the server, correct?
Yes, the underlying communication and architecture within UCSM to the compute still remains the same. All we're doing is now exposing a different means of accessing into your SIMC. Now, as Sameh has mentioned, why would you want to go through in-band versus out-of-band? It's just because you want to separate your UCSM management access, right? So if you're starting becoming more of a cloud provider type of infrastructure, you don't want say to have the application, the OS folks or server folks to access to the UCSM, but they just need access to the servers themselves to install the operating systems or to manage the servers themselves. You can separate that traffic out and just expose the SIMCs to those guys.
Yeah, like a good example might be if you were configuring System Center Virtual Machine Manager. When you add a Hyper-V host in there, you typically will have to provide SCVMM, an IPMI address, and a IPMI user and pass. Instead of having to have that communication go over the management plane, now we can have that go over the same network that the Hyper-V host would communicate on. So.
Exactly. As you start getting to those greater scales and you have more people accessing, going over through 10 gigs will give you that bigger pipe to give you those access to the different compute nodes. As you start have different organizations accessing the UCSM as entirety. So you can have a different SIMC traffic, and then as admin to UCS, you have your own access to the UCS.
And I know that last thing that Sameh was talking about was a different way to get in touch with your KVM as well. Is that something we can show, like showing a direct KVM launch as well?
Yes, we do. I did prepare a demo, a quick video for that as well. So let me show you how to do a KVM. If I can just find my video. So I'm share my desktop. And here we go. Share desktop. So here, actually, for the first part, what we did is to show you how to configure in-band management to set it up really quick, and the demo subsequently is going to show you the KVM. So just for the viewers out there to show how to configure in-band management, the first thing you need to do is...
David, we can't see your screen, so if you could just share your QuickTime this time, that'd be great. It's just a black screen.
It's just a black screen? Okay, apologize.
Yeah, just stop sharing your desktop and just share your screen. Share your QuickTime only.
Yeah. Where is my QuickTime? Disappeared on me. Give me 1 second. Apologize. Here.
Basically, the big change with Direct KVM that we did was really to focus on, like we talked before, about being able to hit the IP address in your browser like you would with UCS Manager, but provide a way to be able to log in without having to open up a UCSM GUI or the KVM manager. So that's what you'll be showing here.
Right. So here for the Direct KVM, let's go ahead and just fast forward to this one here. Okay. So here for the KVM, if you notice from the out-of-band management, you have already an IP address assigned to it, whether it's from your server SIMC or through your service provider SIMC address. You have basically a routable IP address that's exposed here. So if you make notice here, I have 172.25.180.60. So traditionally, the old way of accessing KVM or launching KVM is what you had to do is go through UCSM and just type the virtual IP address on the browser, and it gets you to the standard UCSM Manager, and you can log in there and to configure it. Now, or you can go through the KVM Launch Manager. There's one other thing I forgot to mention is to configure to enable the communication service, because the Direct KVM is disabled by default, and you need to make sure you need to enable it. So here we have SIMC enable, and once you click that, now you should be able to go to the browser. So I'm just going to open up a new tab, and what I'm going to do is just type in the IP address of that SIMC address directly. So 180.60 here, and once I hit there, you notice that I already get the redirect because I don't have my security set up correctly, so it gives me that warning. But now you notice that the splash page or the opening page is different, right? So you notice that we have Cisco UCS KVM Direct. It's no longer the Cisco UCSM splash page, right? So now type in your credentials. You can just launch KVM, and what it does...
These are the same credentials that I would use for UCS Manager. I can have TACACS, Radius, local or LDAP authentication, and have those configured as an authentication domain. That would be my drop-down, correct?
That's correct. So whatever your authentication you set up for with the UCSMs can be extended into your Direct KVM. So if you have different organizations with different management or login credentials or security models, then they will just follow the same policies as those security models that you already have in place.
No, that's great. Well, thanks, David. I think we'll switch over to Jason for a little bit, and we'll talk about, we'll first talk about the Direct Connect C-Series changes that we've done. It would be good to have an understanding of kind of what is supported today from Direct Connect C-Series, as well as what we've added in 2.2.
Sure, I've actually got a nice slide I'll tee up with some visuals.
So while we're doing that, I think we can just start, I think with 1.4 was when we introduced this feature, correct?
Exactly. This started back in 1.4, and it was reliant on a 2248 FEX strictly for the control plane. So fast forward to the 2.2 release, which we've just launched. Now you see, as Sameh mentioned earlier, we've now got the ability to take supported C-Series servers with the 1225 VIC and attach them directly to the Fabric interconnects without the need for a FEX, which really meets that use case where, as Sameh mentioned earlier, the customer just has a couple of rack mount servers. Maybe it really doesn't make sense to go out and purchase the FEX. But I'll give you another visual here. Here's our previous 2 releases, meeting again, different use cases. So in 2.1, that's really where we started single wire functionality, where we're taking management traffic and data plane traffic and running them over the same wire as you see here. But that was done with effects. This is a 2232 FEX, a 10 gig based FEX that operates in both 1 gig and 10 gig mode. So with UCSM 2.1, we have single wire functionality. If you've got a lot of rack mount servers and you want the ability to scale them out and have some levels of oversubscription, it's a great topology there. That does require the 1225, where we've added our single wire support. If you go back to the 2.0 release, where we launched a dual wire, this is actually where we first launched the 2232 FEX. This is where we have support for all the previous adapters, all the previous supported adapters before the 1225. So if you've got a QLogic or an Emulex CNA or the previous P81E, this is the topology you're likely in. So dual wire, you've got a separate control plane and your 10 gig going to the 2232, but that 2232 gives you nice scalability and lets you connect a lot of rack mount servers to a smaller number of ports on the PHY.
No, this is great. I mean, these are three good supported technologies that really have a lot of different, will cover all the different use cases for someone. So let's switch over to some of the compute enhancements. I mean, this is good on the fabric side. What are some of the areas on compute enhancements that you'd like to cover? I think the first one we could talk about is precision boot control.
Sure. I've got a couple of great videos that'll cover precision boot control, and a second video that'll go into some other areas that we had discussed as well.
Okay. So I think we'll go ahead and get that teed up, and just a big quick breather on what precision boot control was. I mean, that was where you can really start getting into configuring both that first level of boot and then that second level of boot. Those specific devices.
Exactly. We have a Flex Flash, an SD adapter that go inside some of our newer servers. So this certainly opens the door to having very granular boot entries to let you boot things like the Flex Flash SD card. Maybe you have internal USB headers and you want to be able to boot specifically from a USB stick inside the blade, or maybe you want to boot from an external USB, something that's maybe hanging on the chassis of a rack mount server or on the dongle, the KVM dongle for a UCS blade. We'll just move forward here. I'm about to create a boot policy. This is, again, the 2.2 release. Lots of differences on this screen that you'll notice.
And Jason, if you could share out that video, that'd be great.
Oh, sure. Oops. There we go. Great. So this is a UCSM 2.2 release, and as I was mentioning, you'll see on the left side under local devices, lots of new options. Very granular, exposure of individual local disk devices. Again, the SD card, the internal, the external USB, and again, local drives as well if you're booting from them. Local and remote CD/DVD. So these could be CD/DVD devices, physically attached to, let's say, the chassis of a server over the dongle, or your traditional remote, your KVM mapped CD/DVD devices. And the same applies for the floppy as well. These could be locally attached or remote through virtual media. And then that add remote virtual devices, the traditional block devices that maybe you're adding over remote KVM, plugging a USB stick in your local laptop or computer and presenting it remotely to the server. And towards the bottom, the same traditional VIX or HBAs. So boot security, this is definitely new, as well as the boot mode of legacy versus UEFI. So as Sameh mentioned earlier, we now have support for booting a full UEFI image, which opens the door for us to pursue support for secure boot. So again, boot security, this checkbox is actually opening the door for secure boot, which really allows you to have establish that chain of trust and allow the UEFI image to again fully validate any of the images that are being booted from it. Again, a lot of enterprise operating systems we see either have support today or are moving forward with supporting secure boot. So we're certainly following right along and want to give our customers that option. And again, I believe the remainder of this video will just showing some examples. You can actually add, another change that wasn't available prior is literally adding multiple entries of the same type. I could add, let's say, multiple NICs that I might want to pixie boot from, put them in a certain order, and then have that order be honored as well. So lots of changes. Again, some very granular options that weren't available prior.
No, this is great. So it's kind of this first step and a few others that we'll be adding over time, where you can specify a lot of that deeper level configuration of being able to be, like we said, very precise in how you specify your boot order. So I know we talked a lot about, with Sameh, about like some of the changes with local disk monitoring. I know that we're working to make in UCS Manager the way you can configure the disks and monitor the disks similar to what we've added in later versions of our SIMC with standalone rack servers. It'd be great if we can talk a little bit about what are the enhancements at a deeper level with local disk monitoring.
Definitely. Yep, yeah. So for anybody that's been following the standalone C-Series side, especially that 1.5 family, lots of changes that we've made. And as Sameh mentioned earlier, that communication channel between the Cisco IMC and our RAID controller, specifically the Mega RAID class RAID controllers, that could be mezzanine form factor or PCI. We've got a nice bridge there, which allows us to have very close monitoring for things like inventory changes, status changes, and such. So lots of good things there. I've actually got a video that will demonstrate some of that near real-time status update that you can get.
So you're saying that you can configure something on that server through like the LSI utility or what have you, be able to reconfigure a volume, add a new volume, or add a disk to a volume, and then we'll be able to see that change in near real time in UCS Manager.
Exactly, and the same extends for for down the road. If a drive should fail, you're getting notification in real near time, not just that the drive has failed, but the impact to, let's say, the virtual volume that's created on that RAID controller. And the same holds true of if a drive goes into rebuilding mode. If you replace a drive, there's going to be a period of time where it's rebuilding. You'll have that status available, and even for your battery, if you've got a BBU on your RAID controller and that goes into a relearning mode, you'll have that status, and you'll know in near real time what's taking place.
It'd be great if we could see that. So if you could share your next video, it'd be great.
Great. So this is again a 2.2 system. I'm going to go into the inventory tab this is a C220 M3 running the latest software. And right away, there's a lot more information exposed in the storage tab. And then again, this is all coming through, again, that channel that we've built between the Cisco IMC and that RAID controller. So very detailed information about your battery backup. In this case, I've got a super cap. You can see under the operation relearning area, we've got support for long-running operations. So things like rebuilding or relearning, you can actually follow that progress in near real time in the UI. And as we move forward down, we talked a little bit about the Flex Flash. Again, we've got very detailed information about the controller as well as the attached SD cards. If something should fail, again, you get a lot of great information both in the UI near real time as well as alerts and faults being sent. So my local disk policy right now is configured for any, and my actual disk config on the RAID controller is with no virtual devices built. So I'm actually going to switch over to the KVM shortly here and run some configurations in the OS. Here's the breakout of the local drives, and again, if we were looking from the operating system side, we'd see very similar information, unconfigured drives in this example. But we're about to go into the OS. We'll go into the Mega RAID Storage Manager tool. This is the OS tool for configuring the RAID controller. We'll go ahead and build a RAID volume on the controller. And once we hit finish, we'll switch back to the UI. And when we go back into the actual disk config, we should see that change. Again, that updates within a second or two. So I've got a RAID 5 in this example.
So in that case, basically what you just, to recap what you did, you went over to the Mega RAID system, it configured it, and then the out-of-band capability is monitoring that change near real time and then displaying that here.
Exactly, and all without the need for any host agents. This is all, sort of below the operating system and at the hardware level, which makes this, I think, really unique and really powerful. And even for the individual drives, we can see that these new drives that we've configured into a RAID are now in a drive state of online where previously they were unconfigured. Now, what goes along with this feature are some new faults as well. So we want to have an indication when, for example, a drive is pulled, like you see here. I've got local disk 1 missing on server 3. I've yanked the drive. I've got a new fault indicating that the virtual drive is degraded for that reason. And even when I go and reinsert the drive back in or replace it and have that drive go back into a rebuilding state, we can actually see that as well in the UI.
So you're really getting a lot of that detail that you couldn't get in the past with UCSM, right from the GUI, and getting the full configuration, the full of all the volumes and disks, as well as the faults when something happens. So that's a lot of great information.
Yeah, exactly. This is, I think, a great implementation and something we really wanted to get to. And I think we've gone into great depth. This next demo here is actually talking about some additional information that we're exposing in our UI. So the TPM, or the Trusted Platform module, is a component on the motherboard leveraged for things like drive encryption or even for secure boot. This is great that we can expose this information that you normally would grab from the BIOS. You'd have to boot the server and go into the KVM to, for example, get the inventory to find out if the TPM is installed, but also to determine the current configuration for the TPM. By exposing this in the UI, I think it's a great time saver for administrators that are using the TPM or troubleshooting the TPM. And longer term, we're working on building the full configuration for the TPM into the UI. That'll be in a future release. But again, this is sort of the beginnings of going in that direction. And what we mentioned earlier, I believe, just to kind of tie off on the TPM and the local drives, is we've got firmware management for the low-level local disks, as well as firmware management if you've got any of our flash adapters from Fusion IO or for LSI installed. Those are now packaged as part of our firmware bundles. I've got one more section of video here, and this is regarding the DIM blacklisting feature that we talked about earlier. So on the Servers tab, we've got a new policy exposed for enabling that blacklisting feature, a DIM blacklisting feature. And I want to just give a quick visual of what this looks like. Once you enable the feature, you'll notice that as you go out into equipment, I'm going to go back into that same rack mount server. This is a C220M3 with a number of DIMMs installed. When we go to the Statistics tab, there's a new area, the Errors tab you'll see, that's got all of that historical information that we were talking about. So again, this feature is about, for one, meeting a few use cases that we've run into in the past. One of which Sameh shared, where if a server should run into an uncorrectable ECC error and crash the OS, there were cases where, in some cases, that server would boot back up. That particular DIM would pass the BIOS MRC check and come back online. But certainly, when you have an uncorrectable ECC error, there's that DIM, for all intents and purposes, needs to be replaced. So having that operating system come back up on that DIM is not optimal. We'd rather have that mapped out. So by enabling this DIM blacklisting feature, we can grab very detailed statistics historically about all the DIMs and make much smarter decisions about when a DIM is deemed inoperable, or to meet the particular use case we talked about earlier, when we might want to map that DIM out on boot. So that it's not exposed to the OS and not exposed to potentially crashing in the future.
That's great. It shows that it gives you a lot more information from the customer's point of view of exactly what types of errors we're seeing across a much longer period. It looks like in the view you have there, we're getting information for in this case up to 2 weeks ago of exactly what that DIM, all the DIMs are doing from an error or an error perspective.
Yep.
No, this is great. I think these features definitely show we keep continually moving that bar with UCS. We're adding a lot of features that we've had a lot of customers ask for pretty heavily. Is there anything? Just want to open it up to the panel. If there's anything else that the panel would like to cover, we got a couple more minutes. Sameh, David, Jason. Okay. Well, if there's nothing else, I don't think we have any questions from our audience. If you have further questions, please feel free to take the discussion to our community's website. So that's communities.cisco.com/UCS. Just for those who aren't familiar, we've added a couple new URLs for some other items with UCS. So we have communities.cisco.com/UCSPE, which is our URL where you can download the UCS platform emulator. So if you have things that you want to, if you want to get any of the versions that we've released from 2.2 all the way back to 1.3, you can go and grab that information. And secondly, for any of the integrations that you want to get, UCS Power Tool or SCOM or System Center Operations Manager, Virtual Machine Manager, etc., any of those tools can be received at communities.cisco.com/UCS integrations. We'll forward those links out over Google Plus here in just a moment after this ends. So again, I want to thank my panelists. I want to thank David, Sameh, and Jason for joining. I want to thank the audience for watching. And if you have further questions, please feel free to take the conversation to communities. Thank you.
Thanks, everybody.
Thank you.
Thanks, everybody. Thanks, Eric.